I am Anil Kumar. Here is another interesting video on trigonometric equations. We'll begin with a mock test, understand what is harmonic wave equation, and take up examination style questions based on our learnings. Enjoy the lesson with our student who is scoring 100% marks. Join Anil Kumar classes, enjoy the journey of success, and develop critical thinking skills. Let us have the class with Arya. Hi Arya, how are you doing?
I'm good, Anil sir. How are you?
Very good, very good. So let me know what happened to your test. Did you get your result?
So on my quiz last week, I got all of them correct, so I got 100%.
Wow, great. Congratulations.
Thank
Excellent.
you.
That's what you deserve. Good. So now let's wind up the lesson with kind of a mock test, right? So I
Sure.
prepared some questions for you, Aryan. We'll go through those questions and let's see what we will learn from those. Now, some of them could be very difficult because I've kept them on purpose so that you learn while we answer these questions. Okay.
Sure.
Right. So let me share with you my screen and then we'll begin answering them. Do you see this page?
Yes.
Perfect. So that is how normally a test paper will be designed for you. We'll begin with very simple questions. The very first question here, this is based on trigonometric identities. It is just a practice test. Is it okay?
Sure.
And remember, the idea is to learn while we go through this test paper.
Simplify each of the following expressions with the techniques specified.
Right.
So the
So
first
what
one
is
is 1 plus tan theta over 1 plus cotangent theta.
yes.
And so they want us to rewrite in terms of sine and cosine. So you can basically just express tan theta as sine theta over cos theta and cotangent theta as cos theta over sine theta. And then 1 plus is you can make the common denominators and then simplify from there using your fractional expressions.
Correct. So the idea of the first question is to review all the techniques. Once we understand all the techniques, we can answer any test question. Perfect. That's the whole idea. So question number one says, if you look at tan theta, cotangent theta, the technique is write them as sine and cosine. That's what we are trying to say. Next
Right.
question, please. 1 plus sine square x over 1 minus sine to the power of 4x. How will you
You
simplify
you
this?
have to factor it. So 1 plus sine squared x and then 1 minus sine 4x. So then 1 minus sine 4x you can use your difference of squares. So that would be 1 plus sine squared x over 1 minus sine squared x, and then the 1 plus sine squared x and the 1 plus sine squared x in the denominator, they cancel out. So you're left with 1 over 1 minus sine squared x, which basically equals to 1 over cos squared x.
That is how you do. Perfect. Next question, please. Question number 3.
They want us to use a common denominator at 1 over 1 minus sine x plus 1 over 1 plus sine x. So basically here, you're going to want to do a cross multiplication. So your top, you could have done that too, but what I would have started
The
with,
answer, right?
yeah. But like what I would have done is I would have gone 1 minus sine x times 1 plus sine x. I would have expanded the denominator, and then turned it into 2 cos squared x, just so that my teacher can see like all the steps.
Yes, yes. Those steps are left for you in between. Finally, you get this answer. And question number 4.
It's square root of 1 plus cos x over 1 minus cos x, and they want us to rationalize to simplify. So basically, you want to multiply the numerator and the denominator by, I think 1 plus cos x.
Correct.
And over 1 plus cos x, and then when you do that, basically you're removing your square root, and then you can expand and simplify from there.
Easy. Then the next set is always prove some identities, right? So
Right.
here we have 4 identities for you. Tell me the strategy to prove the first one. Question number 5.
Okay, so the first one, what I would do is I would actually do the RHS,
Mm-hmm.
because I find that that's much simpler, because in your numerator you have sine theta only, and so from there you can use your conjugate and then multiply sine theta times sine theta, and then 1 plus cos theta times your sine theta, and then you expand from there, and then you get a easier answer.
Great. Question number 6.
It's sine squared. I would use LHS obviously here because there's more numbers. Sine squared theta plus 2 cos theta minus 1 over sine squared theta plus 3 cos theta minus 3. What I would do, I think I would express it both in cosine. So sine squared theta and sine squared theta is 1 minus cos squared theta, and then I'd go from there, factor and then simplify.
You could do that. Or you could write 1 as
Cos squared
plus
theta.
sine square theta. That
Yeah.
will help you to get even a faster solution to this identity. You get the idea?
Yeah.
So writing that will be great. So that is done. Question number 8.
Tan theta, I'd use LHS here, and I'd express tan theta and secant theta in terms of their quotient identities and the reciprocal identities. So tan theta is sine over cos theta, and secant theta is 1 over cosine theta. So I'd express both the denominator and the numerator in terms of that, and then go from there.
So, Arya, if you do that, you will actually land up with at least 6, 7 steps. Here, I'm telling you a trick. You could write 1 as what? 1 plus tan square theta is what?
Right.
You remember that?
Yeah, equals secant squared theta, right?
Right. So we could write secant square theta minus tan square theta
Is equal to 1.
1. So that replacement, we have tan theta minus secant theta. Now this is a difference of square, right?
Right.
So negative of this can come for 1. Do you see that 1?
Ah, I see.
And then you can factor out and cancel and get the answer. So
right, that's so
will
much
be
easier.
a beautiful approach to apply in this case. It will save you half the number of steps. Is that okay?
Right, because in the denominator you have tan theta plus 1, and then you can just use the difference of squares. Yeah, that makes sense.
Square, these things will simplify and you'll easily get your answer, correct?
Right.
Question number 9.
Okay, for this one, I think it's fairly simple. You can cross multiply and then simplify.
Yes. Common denominator, right?
Yeah.
Next one.
The next one, actually, in this one, I think it would be beneficial to use the identity that we just proved above with the cosecant squared theta minus cotangent theta equals 1, and your secant squared theta plus your tan squared theta equals 1. And then you use your difference of squares and then simplify from there, because then you can express each of them as a primary trigonometric ratios.
Yes. So see how easily we've gone through 10 questions. The idea is to review for the exam or the test, correct?
Right.
We need not do all the questions. Once we go through them, we kind of recall what we have already learned, right? And so refresh all those things. And then we know, yes, we know this. And we move along. That's the whole idea, right?
Right.
So that is how you could actually learn and do such questions, right? Now here is a challenge question for you.
Okay.
Slightly difficult, okay? So here's the question.
Let me try and
do this question.
right.
Yes.
Let me do it first, and then if
you tell me the steps, I'll do it for you here also, but you keep doing on your notebook. Tell me,
okay.
What's first step for you?
So cotangent x, I think I would do it in the primary trig ratios because you want to get secant and cotangent.
Yes.
So you'll need to have sine and cosine to do that.
Yes.
Okay, and so from that step, actually from there, I think I might as well I'll guide you through it while I'm writing on my notes at the same time. So from that step there, you want to turn your 1 into sine x over sine x minus cos x over sine x, just so that you can have that as together.
Yes.
Okay. So from there, essentially, you want to turn the numerator into sine squared x, and
Correct.
then that denominator will be sine x times cos x minus cos squared x.
Okay, so you're taking them all, right?
Yes.
Sin x, cos x, sin x minus cos x. So
Yeah.
I'll see these two are same. If I change this sign to negative, you understand?
Yeah.
So I could write this as minus cos square x. Because that is cos square x. Now this is sine. This cos gets multiplied here. So it is
Right.
cube x and that is sine cube x. Slightly more complicated. Do you see this? So I'll
Yeah.
do this so that everybody understands what we have done here. So if you look into the denominator, you will notice that we have sine x here and cos x here. That means I could multiply this by cos x over cos x, correct?
Right.
And this side by sine x over sine x. Now you can clearly see that we have a common denominator, which is sine x cos x times sine x minus cos x. So if I do sine x minus cos x, this term, here we have cos x minus sine x. That will result in negative sign in between, right?
Right.
Negative. So we have sine cube x minus cos cube x in the numerator. You see
Right.
that?
And then from this point on, what you will need to do is basically factor out a sine x minus cos x so that you'll have sine squared x minus cos squared x remaining. And then once you
Correct.
have your
This formula a cube minus b cube,
b cube,
which is a minus b times a square plus ab plus b squared, correct?
right,
Now the numerator will be sine x minus cos x times sine square x plus sine x cos x plus cos square x, correct?
right,
Divided by the denominator, which is sine x cos x times sine x minus cos x.
right. Now, essentially, because we have a sine x minus cos x and sine x minus cos x in the denominator, that will cancel. And then your identity, the Pythagorean identity is sine squared x plus cos squared x, which equals 1. And so you have now 1 plus sine x cos x, and then you have your sine x cos x remaining.
Correct.
So essentially what this
You
will
get
do
this,
is
right?
you'll have your 1 plus your secant x cosecant x.
Perfect.
Because you basically have to separate the fractional expressions so that you can see that properly. Because some common mistake that can happen here is that you just think, oh, sine x cos x removes, and so then you just have, oh yeah, 1 remaining, and then you just put the answer as 1, but no, it's actually that because we're trying to prove the identity.
Perfect. So that becomes a question which is not so easy, I should say, but not very difficult also. So level 2 questions though. So that is how you're going to solve this, and we do have solved. That is the complete solution of this particular question, slightly neater, written down, following the similar steps as we did, right?
Right.
Now, here's the challenge question. So this is a question for the audience. 1 plus cos x plus sin x divided by 1 plus cos x minus sin x equals to cos x over 1 minus sin x. How are we going to solve this question?
I think I'd use the right hand side and then multiply by a conjugate.
Okay, now this question is very tricky. Yes, you can use, but then there's 1 plus cos x minus sin x and 1 plus cos x plus sin x in the numerator, right? So this question really involves a lot of techniques. I think we can discuss those techniques today, and then I'll leave the solution to you.
Okay.
Right.
Sounds good.
Is it okay?
Sounds good.
Okay. So remember, we are talking about terms like 1 plus cos x and plus sin x, right? So let's recall double angle formula. Isn't it surprising? I'm going to use double angle formula to solve this.
Oh, because I think what you might have done is you turned the 1 into cos sine squared x plus cos squared x and then factored from there. But I don't know if
No.
that's what you thought of doing.
Right. So here's just a hint, not a solution. Is it okay? So solution you have to figure out. Okay. So you remember what is sine 2 theta? Sine 2 theta is 2 sine theta cos theta, right?
Right.
We're trying to review the double angle formula now, right? Then we'll come to this solution later, right? So let me do it on a whiteboard. We'll come here with the solution later, or
That's
we can do it here also. Doesn't matter. Okay, and you also remember the formula for cos 2 theta? Cos 2 theta is like,
There's three derivations of it. So there's cos squared theta minus sine squared theta. And then there's also your 2 cos squared theta minus 1, and then your 1 minus 2 sine squared theta.
correct. So we have three formulas there. So 2 cos squared theta minus 1, and we also have 1 minus 2 sine squared theta, right?
Right.
Now, remember this cos squared theta can be, now, so this can be written in so many different ways, right?
Right.
Well, we are interested in x, so I could write, let me rewrite this in a different way. So we can say cos of x is equal to what? Cos of x is 2 cos square x by 2 minus 1, correct?
Right.
So you could replace this cos with 2 cos square x minus x by 2 minus 1, that this 1 will get cancelled.
I understand.
And the sine x you could replace with 2 sine x by 2 cos x by 2. Then once you cancel out 1 from both numerator and denominator, ones are gone. You see that? And this is the other factor, and you know cos x by 2 is common.
Right.
So cos x by 2 is common both in numerator and denominator, so it will cancel out and you will be left with this term. So that is the technique to solve this question easily. Otherwise, it is a very difficult question.
Right.
So I'd like you to try this technique and show me the solution. You get the idea.
Right.
So let that be kind of an assignment, right?
Sure.
Great. So those were a few trigonometric identities which we thought we'll take up. And now we will take up some other questions. Okay. So I thought we'll take now trigonometric equations. Is it okay?
Oh yeah, solving, right?
Solving.
The quadratic and linear ones. Yeah, we did that today.
Yeah. Trigonometric equations. Let me just see.
Yeah, that's what we did actually today.
You did that, right?
Yeah, kind of similar to that.
Correct.
Yeah, that right there, we did that today.
Right. I want to discuss with you a very important equation. Yeah, this is the one. Correct. So we call this a simple harmonic wave equation. It is an application of compound angle formula, which you have learned, right? Many times you will get an equation which will be of the form a cos theta plus b sin theta equals to some number. We say r. Have you seen this many times, right?
Kind of, yeah.
Correct. How do we solve this kind of an equation? That is what we are going to look into now. So to solve this kind of an equation, what we do is we do a substitution. For a and for b, we substitute. So we say, well, let a be equal to because you remember cos a plus b formula. Let me write bigger so that it's easy to understand what we're trying to say here, right? What is
Can't really see. Oh, there. Now I can see what you're writing.
cos a minus b is cos a.
Cos b plus sine a sine b.
Correct. So in the given formula, what are we given? Look at this equation. Let's look at it once again. we are given A cos theta plus B sin theta equals to R times cos of theta minus alpha. You see that theta minus alpha? So
Right.
think this is theta and minus alpha. Do you understand?
Okay, I see.
So that could be written as cos theta Can you correlate? So that is your right hand side, right?
Right.
If I correlate with the left hand side, what are A and B then? Well, in that case, we could say that A is cos alpha because we want to find what alpha is. Theta is already given to us. Okay.
Right.
So we can say, well, cos, let this be A for us, right? And let this be B for us. That is a substitution. Do you see that?
Right.
So we are working on this equation A cos theta plus B sin theta. So now A is basically equals to cos alpha. So we are saying A equals to cos alpha and B equals to sin alpha, correct? So if I
Correct.
take the ratio B over A specifically, then what do I get? I get sin alpha over cos alpha, right?
Right.
Which is tan alpha. So I know what alpha is. Alpha is tan inverse of B over A, correct?
Right.
B over A are the numbers which are given to you. These are the numbers which are given to you. And so we know what alpha is, correct? Because alpha is tan inverse B over A, correct?
Correct.
Now, what is R equals to? So when you
You
substitute, R is A, when we add them and subtract, so we have got this, what is A square plus B square?
C squared?
R square, right? So,
R squared, yes.
yeah, right? So that is how we will get actually R. In fact, when we multiply this by R times this. R.
Right.
So when you do A square plus B, because R cancels here, you understand? R cancels, so we get tan alpha, right?
Right.
You understand this concept? So basically,
Yeah.
yeah, I'll take an example, then we'll understand completely. I'm just trying to give you an hint here. So we can correlate and write down the function. So with this, let's take a concrete example to, okay, with some numbers. Okay, here are some numbers. So the equation is 3 cos theta plus 4 sin theta. Let's do this. Oops. Let me add one page. So we have the equation 3 cos theta plus 4 sin
Right.
theta. We want to write this as R cos of theta minus alpha. Correct? So let us see what are the steps involved and how are we going to do it. Perfect. So as I said, we'll do a substitution. We'll say let 3 equals to R cos alpha, right? And 4 equals to R sin alpha, correct? And therefore, when we take the ratio, that is to say R sin alpha over R cos alpha, what do you get? You get 4 over 3, right?
4/3, right.
So that
And so you
tan
can
alpha,
inverse of 4/3.
alpha is tan inverse of 4. So we
3.
got alpha, correct?
Right.
Now, if I add their squares, what do I get? Let's take up another square. So
The square root
equals to R square cos square alpha.
right.
4 square equals to R square sin square alpha. And if we add them, we get 3 square plus 4 square equals to R square, let's say sin square alpha plus cos square alpha, correct? Which is 1, right?
Which is 1. Right.
So we get R as square root of 3 square plus 4 square. Is that okay? Which is 5.
So it's 16. Yeah, which is 5.
R is 5.
R is 5.
You
When
can,
would they ask these types of questions? I haven't seen this
I'll
in
just give you the question now. We just did the first part. Is just
right.
work with the expression, right? So
Right.
we get this equation that this is now equal to 5 cos of. Can you figure out what is tan inverse of 4 over 3?
Tan inverse of 4/3? Yeah.
Yeah.
Shift. I have to just change my thing into degrees.
Anything, yeah, degrees also will do, anything.
Tan inverse of 4/3. That is 53.13 degrees.
Okay, so we'll say 53.1 degrees. Is it okay? So we
Yes.
get cos of theta minus 53.1 degrees. Is it okay? So that is your value.
Value.
How do we use this expression? That is a very, very interesting thing, right? So many, many ways. One is definitely if I give you a question, my question is 3 cos theta plus 4 sin theta is equal to, let us say, some number which is, let us say, 4, right?
Right.
Find,
Oh,
find theta when theta is between, let's say, 0 to 2 pi, or because we have angle in this, where theta is between 0 to 360 degrees.
right.
How will you do this? If that is the question for you, correct? That is the
Right.
question for you. How will you solve it? Now the idea is, first step is to write this left hand side as an expression like this. Do you see that?
Right. Right.
And now it is an easy question for you. You can say 5 cos of theta minus 53.1 degree is equal to 4. Now you can find the value, correct?
Right. Yeah, because you can just do cos
5
theta
4 over 5,
minus
right?
53.1 equals to 4/5, and then you can take the cos inverse, and then you have theta minus 53.1, and then you isolate the theta.
Yes, and you know you'll get two solutions, and these will
Yeah.
be the two solutions. Find acute angle alpha, right?
Right, because I think cos will be positive, so you'll get two, yeah, in the first and the fourth quadrant.
So you have to work out with this, and that is how you're going to get the solution. So the question actually will be kind of like this.
Right.
All this question, the left hand side should be written in this form: r cos theta minus alpha, and then you solve this equation. You get the idea?
Oh, you always write it in the form of r cos theta minus alpha?
Not necessary. Good question though. We could have written this as r because it was cos. This we could have made a substitution. Let's go for another substitution. If I substitute 3 as equals to, let us say, sine alpha, right? And
Right.
4 as cos alpha, right? Then
Right.
what do I get? I get sine alpha cos theta plus cos alpha sine theta. Is that okay?
Right.
Now that is of the form of sine
A plus b.
alpha plus theta, right? So then you solve this equation. I mean r times, right? You get.
Right.
So then you will be solving a sine equation. Now, another question is why cos is preferred?
I think it's because most questions are given in the format of cos a plus b or cos a minus b. Hence,
Format you could have changed. Cos
yes,
is preferred.
isn't it more simpler to just keep the format that is given than try to
Yeah,
go out
format
of
you
the
will
way to
change.
change it?
Correct, correct. Another important thing about cos is that cos of minus x is equals to cos x. Do you see that?
Right, yeah. So
I
it's easier to manipulate the negative values
Yes,
too.
you could have written as alpha minus theta, which is
Right.
same as cos of theta minus alpha. You get the idea.
Right.
So we want theta minus alpha because alpha gives you the phase shift. Perfect. So
Perfect.
without much rearrangement, cos always works better in these situations. Perfect.
Yes.
So we'll use cos most of the time by default, and we have a huge advantage of this cos of minus x. It is an even function. In sine, sometimes if you forget to change the sign, you get a
You can
wrong
also
answer.
solve function, yeah.
So that is covered if you take cos as your uh, function on the right hand side. Does it
Right.
make sense?
Yeah. It makes sense for the most part. I think I'll just have to like do some more follow-up questions, which are probably on your YouTube channels.
Yeah, yeah, yeah. There are many. So okay. So I'll share with you some questions on the YouTube channel. Uh, So Arya, I'll share with you a very good video from my playlist in YouTube channel. Let us see. We have many questions there. Let us see how to solve such questions.
Sounds good.
So I selected this particular video. Can you see the screen?
Yes.
Now, this is my class with Amy. Amy is actually sharing with me her test paper and the questions which she has selected, right? So she is a student from UK and they are doing the similar kind of course as you are doing. So here are a couple of questions, 7 of them on the screen you can see, right?
Right.
Can you read the very first question?
Solve the equation sine x plus 30 equals to 2 cos x plus 45 for 0, x has to be greater than or equal to 0, but less than or equal to 2 pi.
Correct. So you are given sine and cosine on either side of equality. So, and you have x plus 30 and x plus 45. So kind of good question. You may have to expand, simplify, get the solution, right? You can make
Right.
a note of these questions. How do we solve these questions? Is it okay?
Right.
And figure this out. Actually, we are looking into, and then the next question here is question number 2. Can you please read that question?
If 4 cos 2x minus 2 cos x plus 1 equals 0, find the values of x in the range of 0. X has to be greater than or equal to 0, but less than or equal to 360. For this question, you could just substitute cos of x as your value of like any variable and then solve as a quadratic expression. Can you not?
Cos 2x can be written as 2 cos square x minus 1.
Yeah.
And so you get a quadratic equation in cos x. And
Yeah.
perfect.
And
Next
so,
question. Third question. We came because of the
right?
third question. Yes.
Write 3 cos theta plus 5 sine theta in the form of r cos theta minus alpha, where r has to be greater than 0 and a alpha has to be greater than 0 but less than 90, and hence solve the equation 3 cos theta plus 5 sine theta equals 2 in the range of theta has to be greater than 0 but less than or equal to 30.
So in EdXL, in UK curriculum, they actually kind of give you steps, help you out. How do you solve, right?
Right.
So normally in the test, they will straight away give you only the equation 3 cos theta plus 5 sine theta equals to 2.
Yeah, for us, they don't give us this.
They will not give you the hint which is given earlier. You get the idea?
Yeah, for us, we don't get hints. We just have to.
So you get the question. And it's because of this question that I'm showing you this test paper. It's
Right.
a common question in many test papers worldwide.
Right, because I haven't heard of like a simple harmonic wave until you like showed me today.
Yes. So, yeah, it is not being referred to that, but many physics students know that they use it in many calculations, correct?
Right.
So that's a brilliant question. And then again, question number 4, you can note as a practice test question, identity. We did similar one. We didn't
We
have
did
2x,
this
we had x, right?
Yeah, but for this one, you could have just expanded sine to x and minus cos 2x into their double angle expansion, which would make it actually much easier to solve than the other one because the other one had only sine theta plus cos theta.
Correct. So when you expand cos 2x, you should do it in a way so that that plus 1 gets cancelled.
Yeah, I wasn't going to do it into like cos squared theta minus sine squared theta. I would have just done 1 minus my
Yes,
2
1 minus 2 sine squared.
sine squared theta because like you want to make it into your primary trig ratios and you want sine to be in the numerator to make tan
Correct.
theta.
Got it, right?
Got it.
Next question, please.
Write sine 3 theta in terms of sine theta. So for this one, basically what it's saying is that you want to do it where sine is theta plus theta plus theta.
Yeah, 2
And
theta plus theta. And then again 2
2
theta.
theta plus, yeah, 2 theta plus theta. You could do it like that. And then basically you expand based on the double angle values that you are given and then simplify.
Yeah. And then next question.
The part of that is solve sine 3 theta, which equals to sine squared theta for the restriction given, x has to be greater than or equal to 0, but less than or equal to 360. I think based on the simplification of the sine 3 theta that we receive, you can bring the sine squared theta to the other side, make it equated to 0, because I think all your ratios will be sine when you do that at that point, because you'll be able to turn the cos squared thetas and the cost values into the sign, and then you can just solve as a quadratic by substituting an algebraic
Very good.
variable.
Interesting thing which you note, Arya, is that most of the questions involve proving an identity or getting to an identity, right? And then solving the equation. You get the idea. So both
Yeah.
go hand in hand. Simplify an expression that is like an identity and then solve the equation. So part A was to figure out what is the formula for sine 3x and then
Right.
use that formula to solve the next equation in the given domain, correct?
Right.
Yeah. Next question.
Um, prove that for sine, I believe it's sine 4 theta plus
The
cos
power
4
of-
theta
yeah.
in the brackets equals to cos 4 theta plus 3.
Yes.
Uh,
Next is
so
the
I
equation.
think, but isn't sine 4 theta plus cos 4 theta equated to 1?
No,
Because
is
isn't
square.
it's squared, yeah, but it's like sine squared theta plus cos squared theta.
So when you do sine square x plus cos square x whole square, you'll get cos to the power of 4 also. Plus you'll get a term which will be 2 sine square x cos square x. So that will be an
Right,
additional term.
right. You can't automatically just change
Yes,
it into
yes.
one. You also need that unnecessary part of it. So that
Right.
makes sense.
So that is why this is not an easy question. It's a very good question actually. And then
Yeah.
the next part is using that identity to solve the equation. So look at the next question.
I think this is pretty simple because the identity that you wanted to prove is essentially equated to cos 4 theta plus 3. And so from there, you could have just easily substituted your sine to the power of 4 theta plus cos to the power of 4 theta for that, and then brought your 3 to the other side to simplify the half with the 3. And then you could have, since you have cos 4 theta, you could expand that, or you could change it into a variable and then solve for it.
Correct. Now the idea here is sometimes you are unable to do part A. It is sometimes very difficult.
Right.
You are
So you
unable to do
see the
part
value
but
that
still
was
get
given.
to part B, right? Because you
Right.
know the result. So don't
Right.
lose 4 marks. Even if
Right.
you could not get full 6 marks in part A, try to get 4 marks for part B. That's the whole key, right?
Right.
So, okay. Seventh question, please.
Find the minimum value of the expression 4 cos theta minus 3 sine theta minus 4. Give the smallest possible positive value of x for which the minimum value occurs.
How will you do this question?
4 cos theta 3 sine theta. I think you'd have to use the wave equation, no?
Correct. So the first part will give you the wave equation. R is your amplitude,
Right.
maximum, minimum, but -4. R -4 will give
Yeah.
you the answer plus and minus. You get the idea now?
Right.
Now
Yeah.
in this test paper, we have seen 2 questions related to wave question, and actually they are very tough questions, right? 7 marks for this question. Do you see that?
Right.
And the wave question is 8 marks. Highest marks for those 2 equations, which are related to wave equation, which we discussed in today's lesson.
Right.
But that is the reason of my teaching you wave equation and showing you how in a test paper it has lot of weight. 15 marks. You see that? So that's the beauty. So I think we'll end our class here at this stage and make a note of this. I'll actually give you the link of this video. Okay?
Yes, that would be wonderful.
Yeah, that will be best for you. Okay, I'll stop sharing. And let me just give you the link. Go through this video. Very interesting, excellent questions. And try to do them on your own and then go through the video and understand the strategy which was adopted to solve that. Is it okay?
Thank you.
Okay, great. So we'll end the class here. All the best. See you in the next class.
Bye, no sir. See you.
Thank you. Bye.
Thank you.